Alright, so in this video we'll go over the solutions to the quarter exam in Algebra 2. The first question says, the minimum stopping distance for a moving car is directly proportional to the square of its velocity. Suppose a certain car has a stopping distance of 43 feet when traveling at 30 miles per hour. To the nearest foot, what will be the stopping distance for the same car traveling at 55 miles per hour? So the first thing we want to do is, when we get these types of problems, is we want to underline keywords. So in this case, what we should be underlining is directly proportional. So what does that tell us? Well, that tells us that there's going to be a proportion. So what is the proportion? Well, it says it's directly proportional to the square of its velocity. So you know we're talking about stopping distance and velocity, which means the proportion is v squared over d equals v squared over d. Now, where did I get that? Well, it said that the stopping distance for a moving car is directly proportional to the square of its velocity, not just its velocity, but the square of its velocity. It then goes on to say, if a car has a stopping distance of 43 feet when traveling at 30 miles per hour, so we know that the distance is 43 feet, and we are traveling at 30 miles per hour. So this is 30 squared. And that equals what? Let's see. We know that that equals when the same car traveling at 55 miles per hour. So we know that the velocity at 55 miles per hour has to be squared. And they ask you, what is the stopping distance? What will be the stopping distance for the same car traveling at 55 miles per hour? Good. So that distance we can say is d. So because we have a proportion, we can cross multiply, and we get that 900. Now the 900 comes from the 30 squared. So 30 squared is 900. We get 900d is equal to 55 squared times 43. And we see that that's a very large number. It comes out to be 130,075. We then divide by 900, and whatever we do on the left-hand side, we must do on the right-hand side. And we get 130,075 divided by 900, and we get that d is equal to 144.53, and that will be feet. So when we look at our choices, we see that choice number 3 has to be the correct answer of 145 feet. Alright, for the next question, number 2, which transformation of y equals f of x moves the graph 7 units to the left and 3 units down? Well, from our standard form of functions, we remembered that it was plus minus a. We'll do f in a different color. F of plus minus x. X I should do in a different color because we remember nothing could happen to the x. Plus minus h. And we have plus minus k. And all of those are the parameters of a function, and they all have different things that they do to a function. So we remember that when the graph moves 7 units to the left, that something has to be added to x. So 7 has to be added to x. So we keep the f of x. So we have that f, and we have the x. And in order to move to the left, we need to add 7. So that becomes plus 7. Okay? And then it says, and 3 units down. Well, we know that the 3 down is the k parameter. And to go down, we have to minus k. So that becomes minus 3. So there's our final answer. If we're changing the parameter of the h to a positive 7, which means we move to the left, and changing the parameter of k, which is up or down, we want to go down, so it's minus 3, we see that the final answer is f of x plus 7, that's in parentheses, minus 3. Therefore, the answer is choice number 1. Alright, so for question number 3 reads, which set of ordered pairs does not represent a function? Now, we said that for the ordered pairs to be a function, that every x value can only have one y value. So basically what we have to do is we have to look at all these ordered pairs and see if an x number is repeated, and if it is, see if it has two y values associated with the x value or one y value. So let's look at the first choice. We have 3, negative 2, negative 2, 3, 4, negative 1, and negative 1, 4. So no x value is repeated, so we can put a check next to that. Let's look at choice number 2. We get 3, negative 2, 3, negative 4. Oh, so we have 3 repeated twice. So let's circle 3. So 3 is repeated twice. Now, if it had the same y value, we're fine. But we can see that it has different y values. We have a negative 2 and we have a negative 4. That's a no-no when it comes to being a function. So we know that choice number 2 has to be the ordered pairs that does not represent a function. Alright, now question number 4. A meteorologist drew the accompanying graph to show the changes in relative humidity during a 24-hour period in New York City. Alright, we can see that the graph is relative humidity on the y-axis and time on the x-axis, and it says what is the range of this set of data. So the word that we should be underlining is range. And what does the range mean? Well, the range means what are our y values? What's the range or the interval of y values? So our lowest y value that the graph touches is at 30, and I'll circle that. This point goes the lowest on the graph, and that's at y equals 30. So this is at y equals 30. And now what's the highest point? Well, we can circle that. That's right here. And that's at y equals 80. So the range is the highest point to the lowest point. So we can write this in interval notation as bracket 30, comma 80, close bracket. We could also write it as 30 is less than or equal to y, which y is then less than or equal to 80. Now, is that a choice that we have here? Well, let's look. Yep, we see choice number 3. So we can circle it, and we know that that is our correct answer. Alright, so the next question asks, what is the turning point or vertex of the parabola whose equation is y equals 3x squared plus 6x minus 1? Well, on the test, we were supposed to put this into the calculator, and once the parabola is graphed, look at where the vertex is. But what we can do is, since we learned the formula to find the vertex, I will show you now on exactly how to find the vertex of this function. So we remember from class today that the x component of the vertex is equal to the negative b over 2a. Now for the test, you shouldn't have known this. For the test, you would just expect it to plug it into the calculator and find the vertex. But now, since you have the equation, we can find what the vertex is using algebra. So negative b would be negative, and we substitute a 6 in, over 2 times our a value. So we substitute a 3 in. That's our a value. And we get that negative 6 is equal, negative 6 divided by 6. So therefore, our x value is negative 1. Now, where do they get the a's and b's? Well, we remember that the standard form of a quadratic is x squared plus bx plus c. Now, once we have the x value of our vertex, we can plug it in to get the y value of our vertex. So we have y equals, and we'll plug it right in. 3, substitute in our x as -1 squared plus 6 times -1 minus 1. So let's see what y equals. We get that y equals, well, -1 times -1 is 1, times 3 is 3, plus a -1 and a 6 is a -6 minus 1. And we get finally that y equals -4. Therefore, the vertex, I'll write in a different color. The vertex is at -1, -4. And is that one of our choices? Yep, we can see that choice number 2 must be the correct answer. Alright, so question number 6 reads, which equation is represented by the graph below? Well, we know that that's an absolute value function, so we know we can name this as f of x equals absolute value x. However, we see that absolute value x, we know, is at the origin, so it's supposed to be right here. But this function is 1, 2, 3 units below where it's supposed to be. So we know that that k value must have changed. So we can put that k value changed. Alright, now, we also know that the standard form of an absolute value, I'll write up here. So the standard form is f of x equals a absolute value x minus h absolute value plus k. So since we know k is the parameter which moves our function up and down, it must be a -3 because it's 3 down from the origin. So if we were to write this using standard form, we would have f of x is equal to the absolute value x. There is no a parameter and there is no h parameter. There's just a k parameter, -3. When we look at our choices, we can see that choice number 3 has to be the correct answer. Another way that we could have done this problem is, since the test gave you 4 different choices, we could have graphed each of the choices to see which graph on our calculators looked like the graph that was displayed on the test. If you did it that way, you are still got the same answer of 3. Alright, so question number 7 is again an absolute value question. The diagram below shows the graph of y equals absolute value x minus 3. Which diagram shows the graph of y equals negative absolute value x minus 3? Well, we know that the absolute value of x minus 3 is 3 over to the right from the origin because it's a -3. But what happens when there's a negative outside? So again, I'm going to write the standard form of absolute value, which equals y equals a absolute value x minus h plus k. So according to what the test is presenting us, we want to know what happens when there's a negative outside of this absolute value sign. Well, we know this negative right here, which I'll circle, deals with reflection horizontally. And in this case, since the function is on the, so like we said, this function is located on the x-axis. So therefore, our reflection is going to be horizontally on the x-axis. So we can draw that graph that looks exactly the same, like so. And when we match that up to our choices, we can see that choice number 4 is the correct answer. Another way that we could have done this is, again, since they presented us with an actual function of negative absolute value x minus 3. All you had to do was put that into the calculator and graph it to see which of the choices was the correct answer. Alright, question number 8 reads, what is the value of the y-coordinate of the solution to the system of equations x plus 2y equals 9 and x minus y equals 3? The easiest way to do this was to put this into the calculator, graph it, and then do second trace intercept, and you would be able to get the x and y coordinates of the intersection point. Algebraically, I will show you exactly how to do this. The first thing we want to do is we want to make sure that both of these equations are equal to the same thing. So the easiest way we can do it is, let's solve for x. So we have x minus y equals 3, and we have x plus 2y equals 9. To make them both equal x, we could bring over 2y, and we have that x is equal to negative 2y plus 9. The equation on the right hand side is ready to go. So since, not yet, we would have x equals y plus 3. Now both equations are ready to go. So what can we do? Well, we can bring both equations together since they're both equal to x, and we can set them equal to one another. So we have y plus 3 equals negative 2y plus 9. And now we must solve for y. So we have, let's bring over a 3, that becomes 6, bring over a 2y, bring over a 2y, and we get 3y is equal to 6. We divide by 3, and we get that y is equal to 2. The question says, what is the value of the y-coordinate? Since we found the y-coordinate, we know that the answer must be choice number 2. If we were to also find the x-coordinate, now that we knew the y, all you have to do is plug it in. So we can say plug in to either equation. Because again, it's the intersection of the two lines. So they both have the same x and y coordinate. So we can say that x minus y equals 3. We can plug in negative 2, so it becomes negative, and we plug in that 2, 3, and we can see that x equals 5. But the question asks for the x coordinate, x for the y, so the choice would be 2. Alright, so question number 9 reads, which coordinates represent a point in the solution set of the system of inequalities shown below? Well, in class what we did, we took these inequalities, we graphed them, and then we used the test point to see what their solutions were. But now we're given solutions. So the easiest way to do this problem is to put those solutions back into the inequalities and see if they satisfy both inequality 1 and inequality 2. So we'll name this as inequality 1 and this is inequality 2. And they both have to be satisfied by the solution. So if we make like a little chart and we have 1/2 x plus 13, and that's greater than or equal to y. And then we have over here, we'll draw a line, we have 4x plus 2y is greater than 3. We can test these points. So let's test these points. So on the first, number 1, we have negative 4 and 1. So we put 1 in for y. Is 1 less than or equal to 1/2 times negative 4 plus 13? And we get that negative 2 plus 13 has to be greater than or equal to 1. And ultimately we get that 1 is less than or equal to 11. So that's true. So that works for one of them. Does it work for the second one? Well, let's see. 4 times negative 4 plus 2 times 1 must be greater than 3. So we see it's negative 16 plus 2 must be greater than 3. Well, right away we see that this doesn't work. We have a negative number, negative 16 is not greater than 3. So we put an X and we must move on. Alright, so since choice number 1 didn't work, I'll cross it out. So I'm going to cross out choice number 1. And we are going to move on. So I'll erase this work. And we will, oh, let me leave the important part. So I'm going to erase this work right here. Okay. I'm going to erase this work, and then we'll move on. Beautiful. All right. Now for test point number 2. I'll cross out 1. Test point number 2, 2, 2. So let's see if that works. Well, if we put in negative 2 is less than or equal to 1/2 times negative 2 plus 13, does that work? Well, we see that negative 2 must be less than or equal to negative 1 plus 13. So we know this is going to work. Negative 2 is less than or equal to 12. Alright, so we see that one works. Let's try the other side. We get 4 times negative 2 plus 2 times 2 must be greater than 3. So we see that negative 8 plus 4 must be greater than 3. Right away, we see that doesn't work. So we put an X. And now we can cross out option number 2. So let me delete this. We'll cross out option number 2. And we will get rid of our work and work the next set of coordinates. Alright, the next set of coordinates is 1, negative 4. Alright, so if we put negative 4 is less than or equal to 1/2 times 1 plus 13. Alright, we see that negative 4 must be less than or equal to 1/2 plus 13, and we see that this is true. Let's try over here. We see that 4 times 1 plus 2 times negative 4 must be greater than 3. Right away, we see it's not going to work because we have a 4, we have a minus 8, and that has to be greater than 3. It's going to be a negative number. So we have to cross that out. That doesn't work. So erase this. And we could put a line through option number 3. So that only leaves one more left. Let's do it just to make sure we didn't make any mistakes. And we see it's 2, negative 2. So the y is negative 2. So is negative 2 less than or equal to 1/2 times 2 plus 13? Alright, right away you see that that's going to work. We have a large number, so that's a check. Let's see over here. 4 times 2 plus 2. Sorry about that. 4 times 2 plus 2 times negative 2 is greater than 3. We see that 8 plus negative 4 is greater than 3. We see that 4 is greater than 3. So there's a check too. So we can see that option 4 must be the correct answer. Alright, so question 10 reads, the diagram below shows the graph of which inequality? Well, we could have solved this 2 different ways. The first way we could have done it is to graph all of the 4 choices and see which graph on a calculator resembles the graph that's on the test. The second way we could have solved this was without the calculator. So the first thing you want to do is you want to see where they got x minus 1 from. We could see that we got that from the y-intercept being negative 1, which is right here. And we can see that the slope of this line is 1. So we could write the equation of this line as y equals x minus 1. Okay, now when we're talking about inequalities, there's two things that we have to look out for. The first thing is a dotted line or a solid line. Well, what does the dotted and solid line mean? Well, dotted means that we're not including the points on the line, which is less than or greater than. And a solid line means we are including it, so we will add that equal to component. So right now we know that y must be greater than or equal to or less than and equal to x minus 1. But we don't know which one yet. So because we know that, we can cross out choice number 1 and choice number 3. So we know it's either going to be choice number 2 or choice number 4. So how do we find what side is shaded and which one makes sense? Well, let's choose a test point in the shaded area. So if I choose the test point, I'll put in green as, let's say, 2, -1, which is right here. We know that this point right here satisfies the inequality. And let's put that into our inequality. So we're choosing test point 2, -1. So when we put that in, we get that -1 on the left-hand side, and we get 2 minus 1 on the right-hand side. So ultimately we get -1 and we get 1. So we know that when a point is in the solution, the inequality has to make sense. So if we had a question mark in between these two numbers, which inequality symbol would make this make sense? -1 is less than or equal to 1 would make this inequality make sense. So therefore, the answer to this is y is less than or equal to x minus 1. Now, is that a choice? Yes, we see it's choice number 4. Alright, so question 11 reads, using the substitution method, Ken solves the following system of equations algebraically. Which equivalent equation could Ken use? So the first thing is, let's look at our choices. And we see that the choices look very similar to the bottom equation, except the y component of that bottom equation, which is right here, I'll circle it, is missing. Ken substitutes something in for that y. Well, what can he substitute in for a y? Well, he would have to substitute another equation where y equals something. So if we would take the first equation, let me label it as 1 so you know exactly where I'm getting it from. If I was to label this 1, and I was going to work on equation number 1 down here, and we have that 2x minus y is equal to 5. Let's solve for y. Now, how would I do that? Well, I would bring over 2x, I would bring over 2x, and I would be left with negative y is equal to negative 2x plus 5. Now, we almost got y by itself, but there's that negative attached to it. So let's divide by a -1 and divide the entire right side by a -1. And we are left with y is equal to 2x minus 5. So now that we have y equal to something, let's do what Ken was doing and substitute in the bottom equation. So I'll name the bottom equation 2. And I'll do that over here. He substituted in that y. So we have 3x plus 2. We got 3x plus 2, and now we're going to substitute in that y. So what does y equal? Well, we found that y equals 2x minus 5. So y equals 2x minus 5. And that whole thing equals -3. So when we look at our choices, we see that choice number 1 is our correct answer. Alright, and question 12 reads, which equation represents the function shown in the accompanying diagram? Well, we can see that this function is an absolute value x function, so we can say that f of x is similar to absolute value x. The problem, though, is that absolute value x vertex is at the origin. It's supposed to be here, but it's moved up 1 unit. So we know that that has to be a plus k, and our k is equal to 1. So we can say that the k is equal to 1. It's 1 unit up. we're talking about this right here. So I'll draw that. 1 unit up. So when I was to write this new function, it would be called f of x is equal to absolute value x plus 1. And we can see that the choice should be 1. Now, another way we could have done this was, again, we could have graphed each of the 4 choices and see which graph represented the graph that is currently on the test. Doing it that way, we would have seen again that the correct answer is choice number 1. Alright, question 13 reads, which value of r represents data with a strong negative linear correlation between two variables? Well, we said a linear correlation, which is defined by r, has to be between 1 and -1. And it's very strong when it's approaching -1 or 1. So this is asking for a strong negative linear correlation. So we already know that choice number 1 cannot be. So we could cross that off. Why? Because it's less than -1. We also know that it can't be choice 4 because choice 4 is a positive value. It's asking for a strong negative value. So it's either between choice 2 or choice 3. Well, choice 2 is a very strong negative because it's closer to -1 than -0.14. So the choice would be choice number 2, -0.89. That's the closest value to -1 without going over -1. Alright, 14 reads, as shown in the table below, a person's target heart rate during exercise changes as the person gets older. Which value represents the linear correlation coefficient, rounded to the nearest thousandth, between a person's age in years and that person's target heart rate in beats per minute? Well, this question is solved by using the stat function on our calculator. We plug in all the information into our table, and using line reg, we're able to find the linear correlation coefficient. And by doing this, we find that the coefficient comes out to be -0.999. Now we have to remember, this is the r value, so I'll put the r value. It is not the r squared value because this over here is our r squared value. If we were to square 0.999, it would equal 0.998. So we want to make sure we do not confuse the r with the r squared value. We want the r because the r represents the linear correlation coefficient. So the correct answer for this problem was choice number 1. Alright, so next question reads, if f of x equals x in the numerator divided by x squared minus 16, what is the value of f of -10? Well, what does f of -10 mean? It means that we are going to substitute the x with -10. So we can write this as f of -10 equals x over x squared minus 16. So we put in -10 in for x, we get -10 in the numerator divided by -10 squared minus 16. So we get -10 over 100 minus 16, and we get -10 over 84. When we break that down, simplify it, we can see that 2 goes into 10 5 times, and 2 goes into 84. We can see 42 times. So the correct answer is choice number 2. Do we see how we got that? I'll put it alongside. We had -10 divided by 84. We see that 2 goes into 10, -5, and 2 goes into 84 42 times. That's how we got that answer. Alright, 16 reads, which transformation of y equals f of x moves the graph 7 units to the left and 3 units down? Alright, again, we know that 7 units to the left, this is our positive h value. Moving to the left, it's positive, and 3 units down would be our negative k value. So when we write that standard form of plus minus a f of plus minus x plus minus h plus minus k. Of all the possibilities that function could be called, we see that we are manipulating the plus h, so it's plus 7, so we can write it as f of x plus 7, and we're manipulating 3 units down, which is okay, so we need a minus 3, and when we match it up with our choices, we can see that choice number 1 must be the correct answer. Alright, question number 17 reads, which graph does not represent a function? Like we learned in class, a function is represented by ordered pairs where an x value has only one y value associated with it. Another way we can see from a graph if it's a function is if it passes the vertical line test. That will prove that for any x, there's only one y value. So if we use the vertical line test for all of these, we can see that if I was to use vertical lines, that there is exactly one y value for every x which is there. If I try choice 2, again, every x only has one y. For this one, maybe a little confusing, but they're just points. And again, if I draw lines through the points, there is not one x value that has a multiple y value. Okay, now this is where we start to understand where there might be a problem. If we continued, in case we didn't see what this looks like, if we were to continue this function, we can see it would look something like this. And if I were to take a line and go straight down, we would see that at this point right here and at this point right here, that x value has two y values associated with it. Therefore, this function right here cannot be classified. Well, I should say this graph right here could not be classified as a function. Alright, question number 18 reads, the graph below shows the function f of x. Which graph represents the function f of x plus 2? Well, we can say that plus 2 inside the parentheses is our plus h value. And we know that when it's a plus h, we are moving to the left. So let's look for a graph that moves to the left. It doesn't move up, so we could cross off 3. It doesn't move down, so we could cross off 4. So it could either be 1 or 2. 1 moves to the right, where most people may think x plus 2 moves. However, in class we showed exactly why a graph moves to the left when we add 2 to the x value. So we know that choice number 2 has to be our graph. Alright, the graph of the function f of x has been translated to the left 3 units and down 5 units. Which of the following represents the new function? Again, when something is translated to the left 3 units, we know that this is a minus h, and down 5 units, we know that this would be a minus k. So let's look at our choices that shows a minus h and a minus k. If our standard form, again, is plus or minus a f of plus or minus x plus or minus h plus or minus k, again, shows all the possibilities a function can be called, we can see that the h must be inside the parenthesis. So it's a minus h because we're moving left. Oh, I caught myself. It should be a plus h. We're moving left, so it should be a plus h. So we're inside the parentheses. We're moving left 3 units, so it's a plus 3. So we have f of x plus 3. And we are moving down k units. 5 units is our k value. So outside the parentheses where the k parameter is, minus 5. When we match this up with our choices, we see that f of x plus 3 minus 5 is choice number 3. Moving on to question 20. What is the graph of the solution set of absolute value x minus 1 is greater than 5? So, I'll do the algebra right on the actual inequality. The rules of inequalities with absolute value signs must be that the absolute value has to be by itself. So we can see that 2x minus 1 is by itself. So once it's by itself, we know that we would have to make two inequalities when it's greater than. So let me circle the greater than, because less than we have another rule. But greater than, we would make two inequalities. One that's 2x minus 1 is greater than 5. And another one that would say 2x minus 1 is less than negative 5. So once we solve both sides, we see that 2x is greater than 6. We divide by 2, we divide by 2. We see that x is greater than 3. The other side, we bring over the 1, and we see that 2x is less than negative 4. We divide by 2, divide by 2, x is less than negative 2. So we look at a graph. Our boundary points are negative 2 and 3, and since it's a greater than or less than symbol, they are not colored in. We can see from our choices, none of the circles are colored in. Great. So now we have to think about what direction is our solution going in. Well, let's take the first one. X is greater than 3. So the solution has to be greater than 3. So we know that this is correct. I'll put a check over here. And this is correct. So we can cross off 2 and we cross off 4. Now our other point is negative 2. Since it's negative 2, right away we can cross off 3. But let's see if it's correct. It's saying all x values less than negative 2. Well, this is correct. So our choice would be choice number 1. Alright, question 21 reads, what is the solution set of absolute value x minus 2 is equal to 3x plus 10? Alright, so we said before that once the absolute value is by itself, we can then have two equations. And our two equations that we have to write are x minus 2, let me erase that little mark, is equal to 3x plus 10. And there's another line where x minus 2 is equal to negative 3x minus 10. So now we have to solve for x. So we bring 2 over to one side. We bring the negative 3 over to the other side. And we have that negative 2x is equal to 12. We divide by negative 2. We divide by negative 2. And we have that x is equal to negative 6. So that's one option. The other side, let's bring over the 2 the same way. We bring over the 2. We bring over the 3x. And we get that 4x is equal to negative 8. We divide by 4. We divide by 4. And we have that x could equal negative 2. Now, with absolute value equations, we have to make sure that our x values are accurate. We have to check them, because not every time we solve for an x will it work in the original equation. So for each x value, let's check. All right, so let's do the negative 2 first. I'll do it up here. If I have absolute value negative 2 minus 2, does that equal 3 times negative 2 plus 10? Well, let's think about this. Negative 2 and negative 2 is a negative 4. So it comes out of the absolute value as 4. Does that equal negative 6 plus 10? Yep, it does, because 4 equals a negative 6 plus 10, which is 4 equals 4. So we know that negative 2 works. Let's box that in. This is definitely a solution. So if that's definitely a solution, let's cross off all of our choices. Well, We can't have no solution because we already proved that there is at least one solution, a -2. And we know it can't just be -6 because it has to include -2. So now let's test -6. So if I throw -6 into the original equation, I get -6 minus 2 is equal to 3 times -6 plus 10. Does this equal? Well, we see that -6 minus 2 is a -8, so this pops out the absolute value as 8. And is that equal to -18 plus 10? Well, we see that 8 does not equal -8. So we see that x minus 6 cannot be a solution. Therefore, the only answer to this problem is choice number 2. The solution is -2. Alright, so for question number 2 reads, the solution set of absolute value 3x plus 2 is less than 1. Contains what? Does it contain only negative real numbers, only positive real numbers, both positive and negative real numbers, or no real numbers? Well, there's a couple ways we can do this. Let's solve for our x. All right, how would you do that? Well, we have a less than symbol. So when we have a less than symbol, I'll circle it. We have a certain rule. What is our rule? Well, we sandwich. So we sandwich the 3x plus 2 in between a 1 and a -1. Now, whatever you do in the middle, you have to do to both sides. And we get that 3x is between -1 and -3. When we divide by 3, divide by 3, divide by 3, I'll write the finished product over here. I'll write that over here. We see that x is between -1 and -1/3, like so. All right, so when we look at our choices, the solution set contains only negative real numbers? Yes, it contains negative real numbers. Does it only positive real numbers? No, there's no positive numbers in the solution set. Both positive and negative real numbers? Nope. Doesn't contain any of those. And no real numbers. Well, we know they're real numbers, so that's out. So we can see that the only choice that works is only negative real numbers between -1 and -1/3. So the correct answer would be choice number 1. Alright, question 23 reads, find the slope of a line parallel to the line whose equation is 3y plus 2x minus 6. The first thing we need to do is put it into slope-intercept form. So when we write 3y plus 2x equals 6, we want to bring over a 2x, we bring over a 2x, and we get that 3y is equal to -2x plus 6. We divide by 3, and we divide the whole thing by 3. We get that the equation of the line in slope-intercept form is y equals -2/3 x plus 2. Well, the question asks, find the slope of the line parallel to the line whose equation is this. Well, let's box in the slope. The slope is -2/3. Parallel lines have the same slope. So, since they have the same slope, the only choice that works is choice number 1, which is -2/3. Alright, question number 24 reads, find the equation of the line parallel to the line whose equation is y equals -3x plus 5 and whose y-intercept is -5. So, like we just answered, we know that parallel lines have the same slope. So let's box in the slope. So we know that the line parallel to that line has to be y equals -3x. Same slope. However, in the question it says whose y-intercept is -5. So this second line doesn't have a y-intercept of +5 because then they would be the same line. To be different line, they must have a different y-intercept. So their y-intercept is -5. So here's the equation of a line that is parallel to the original line of y equals negative 3x plus 5. When we look at our choices, we see that choice number 4 is our answer. And finally, question number 25 reads, what is the solution of the system 7x plus 4y equals 2 and 9x minus 4y equals 30? Well, to solve a system of equations, we can do it two ways. Number one, we could have plugged it into the calculator, graphed it, and used second trace intercept to find what its solution was. Or we can solve using elimination. Solving algebraically, we would set this up as 7x plus 4y equals 2, and directly under it we would write 9x minus 4y equals 30. Through addition, we can see that the y's would cancel. So when we add these together, the y's cancel, and we are left with 16x is equal to 32. We divide by 16, we divide by 16, and we see that x is equal to 2. So our solution has an x coordinate of 2. So once we know that, we can cross off choice number 3, and we can cross off choice number 2. The only options we have left is choice 1 and choice 4. Once we have the x value, we could plug it in to any of the equations. So let's plug it into the top one. So if we have 7 times 2 plus 4y equals 2, what does y equal? Well, 14 plus 4y equals 2. When we bring over the 14, we minus the 14, or subtract the 14, we get that 4y is equal to negative 12. When we divide by 4 and divide by 4, we see that y must equal negative 4. So our solution is 2, negative 4. When we look at our choices, 2, negative 4. I apologize. Negative 12 divided by 4 is a negative 3. So when we look at our choices, we're looking for a solution of 2, negative 3. And we see that choice number 1 is the answer.